my name is Juan and welcome to this week's video. Today we're going to talk about the right triangle trigonometry. Let's get started. Okay, just to make it clear, a right triangle is just a triangle that has one angle that is equal to 90 degrees. This one, for example, is a right triangle. It has a 90 degrees angle and the side that is opposite to that angle is called the hypotenuse and the other two sides are called the legs. And if you want to go fancy, you call them catheti. Catheti. Now let's talk about the trigonometric identities. We're talking about the sine, the cosine, and the tangent. Something that is really important here and something that you have to get straight before we continue is that if you have this angle in here, still this side is going to be the hypotenuse because it's the opposite of the right angle. And to this angle, this side is going to be the opposite side. And this side is going to be the adjacent. Adjacent means that touches the angle. So this side is the only one that touches the angle besides the hypotenuse, right? Okay, now that you know that, we're going to talk about SOH CAH TOA. SOH CAH TOA is just a way to remember that the sine of an angle is equal to the opposite side divided by the hypotenuse. The cosine of an angle is equal to the adjacent side divided by the hypotenuse, and the tangent of an angle is equal to the opposite side divided by the adjacent side. Just to make sure you understand this, the sine of this angle is equal to this side divided by the hypotenuse, and so on. For example, if we were not talking about this angle and if we were talking about this one instead, the opposite of that angle is going to be this one. And the adjacent is going to be this one. The hypotenuse is going to be the same, but the other two sides are going to switch. Okay, so in this example, this person wants to know the height of the building. The person walked 100 meters in that direction, starting from the building, and to see the top of the building, that person has to look up in an angle of 60 degrees. This is a right triangle. This is an angle of 90 degrees, and this is an angle of 60 degrees. Personally, what I like to do is know what I have. First, since we know this angle, we know the sine, the cosine, and the tangent. So we have the sine, the cosine, and the tangent. And we know this side. Is it the adjacent? Is it the opposite? Well, in this case, we're talking about this angle. And this side is touching that angle. So it's the adjacent. So we have the adjacent here, and we have the adjacent here. Now, how I like to think about this is that if you know 2 out of the 3 letters, you can find the other one. So here we just know one of the letters. We know the sine. We cannot find neither the opposite angle nor the hypotenuse. Here we know the cosine and the adjacent. We can find the hypotenuse. And here we know the tangent and the adjacent. So we can find the opposite. However, we have to think about what's easiest for us. So we're looking for the height of the building, which is the opposite side of this angle. So we're looking for this side. Are we going to look for the hypotenuse? We actually don't care. We are looking for the opposite side. So we're going to use this formula that says that the tangent of an angle is equal to the opposite, O sub P, over the adjacent, right? And here we're just going to solve for the opposite side. Solving for the opposite angle, we end up with something like this, and here we just sub in our numbers. So the adjacent side is 100 meters times a tangent of 60 degrees, and our answer is that the height of the building is equal to 173.2 meters. Now for our second example, we have the following triangle. I couldn't come up with a situation in the real life that would suit this triangle, but anyway, we have a hypotenuse that is equal to 75. It can be meters, yards, whatever you want, and one of the sides is equal to 20, and we have to find theta. Again, let's see what we have. So we have the hypotenuse and the hypotenuse. We're looking for the angle, so we don't have neither the sine nor the cosine or the tangent, and we have this side. But what is it from this angle? Is it the opposite side or the adjacent side? As we can see here, it's touching the angle, so it's the adjacent side. So we have the adjacent side and the adjacent side. Again, we're looking for our angle, so we can solve for the sine, the cosine, or the tangent. It doesn't matter which one of those. Now we have to look for the equation that best suits our needs. For example, in these 2 equations, we only have one of the variables. We cannot solve for the other 2. In this one, we have 2 of the variables, and we can look for the cosine of theta. So we can use this formula that says that the cosine of theta is equal to the adjacent over the hypotenuse. Let's sub in our numbers. We have this equation and we have to solve for this angle. However, there's a cosine in front of that angle. To get rid of that cosine, we're just going to take it and take the inverse on the other side of the equation. So theta is equal to the inverse cosine of 20 over 75. In doing the math and punching our numbers in the calculator, we find that the angle is equal to 74.5 degrees. So that was it for this video. I really hope you guys enjoyed it, and if you did, please don't forget to give it a big thumbs up and subscribe if you haven't yet. If there's a specific topic that you want me to go over in my next videos, please just write it in the comments down below, and I'll see you all in my next week's video. Bye.
Don't worry, be happy.